Hello and welcome to Everything Explained. I'm your host, and today we're diving into a question a lot of us wonder about: how does the brain form memories? You might forget where you left your keys, then suddenly remember the lunch spot from last summer. The answer isn't a single light bulb moment. Memory is a process, happening in many parts of the brain, with steps that can be short or long, easy or tricky. We'll walk through encoding, consolidation, storage, and retrieval, and we'll mix in examples and simple analogies you can take with you. Think of memory as saving a file. The moment you notice something, what you hear, see, or feel, is the encoding stage. Your senses feed your brain, attention focuses on what's important, and chemical signals hop around to help link the pieces. The hippocampus, a small seahorse-shaped structure, acts like a librarian. It binds together the spots, sounds, and feelings of a moment into a single memory, a file that sits in your brain ready to be opened later. Right after something happens, that memory is fragile, like a file that's still open on your computer. During consolidation, the brain strengthens those connections and moves the memory from the hippocampus into wider areas of the cortex, the outer layers of the brain where knowledge lives. Sleep helps a lot here. During deep sleep, the brain rehearses the day's events, a bit like the librarian reshelving books and labeling them for easy finding later. This is why a good night's sleep often makes a new skill or fact feel solid the next day. When you're awake, emotions can color the memory too. The amygdala, the brain's emotional center, tags some memories as especially important so they get reinforced. Memories aren't stored in one tiny box. The hippocampus acts as a temporary hub, linking details: where you were, who you were with, what you saw. Over days and weeks, those details spread to the cortex, the big network that stores knowledge, language, and experiences. Different kinds of memories live in different neighborhoods. Facts and general knowledge lean on the front and side parts of the brain. Memories of how to ride a bike, procedural skills, live in the basal ganglia and cerebellum. The emotional tint, even a scary moment, stirs the amygdala and can make the memory stronger or weaker. It's like a concert. The same memory has notes from many players, playing together. When you try to remember, you bring together cues: what you see, who you're with, the place you're in, and you reconstruct the memory. Sometimes it's spot on, sometimes it's a little off. Each time you recall something, the memory can be updated in a process called reconsolidation. That's one reason memories can change. New information or new feelings reshape the old file. It also explains why eyewitness accounts can differ. The brain isn't just playing back a recording, it's editing it in the moment. Inside the brain, there's a basic process called long-term potentiation, or LTP. When two neurons keep firing together, the connection between them gets stronger. Picture it as laying a path through a field. The more you travel it, the clearer and easier to follow it becomes. A molecule called glutamate is a key signal, and a receptor called NMDA acts like a gate that opens only at the right moment. This timing detail matters. The brain learns best when signals line up in a precise way. LTP is one of the main ways the brain rewires itself to store memories. The hippocampus is a busy workshop for this process, but over time, the strengthened connections spread into cortex areas, making recall faster and more reliable. The brain can even grow new neurons in the hippocampus, a process called neurogenesis, which stays active a bit in adults. Exercise, learning new skills, and a stimulating environment can nudge this process along. What affects memory, and how can you give it a boost? Memory is flexible and changeable. Stress can help with remembering exciting events but hurt normal memory if it stays high. Sleep, regular exercise, and a good diet help the brain stay plastic, ready to form and adjust memories. Paying attention is crucial. When you're distracted, encoding isn't strong. Spaced practice or revisiting information over time beats cramming. A mnemonic, a story, or teaching someone else the material also helps seal the memory. And remember, engaging multiple senses, sight, sound, touch, can make memories stick better. So, memory isn't one single thing you either have or don't. It's a dynamic process that starts with encoding, travels through consolidation, lands in a broad network of brain areas, and comes to life again each time you recall it. Your brain uses emotion, sleep, and practice to keep those memories alive, for better or worse. The more you understand the steps, the more you can help your brain keep the parts of your life you care about reachable when you need them. Thanks for listening to Everything Explained. Until next time, Nurture your brains, trust the process, and keep your memories close enough to reach when you need them.